Hello, everyone. Glad to be here with you today to talk about all things testing. So as we heard earlier today, we have some new testing features in Terraform and in Terraform Cloud. So that's what we're going to be going over today. And when we talk about testing our Terraform code, what we're really focusing on is testing modules. Modules are that fundamental reusable construct in Terraform that we use to standardize our best practices, our recommended approaches, our approved approaches for our consumers, right? Us as module authors, making those available to downstream consumers. And we can really think of that module like a contract. The inputs, the outputs, the interface, the behavior is a contract between the author and the consumer, the user, just like really any other API is. And just like an API, changes to that interface or to the inputs and outputs or the behavior can have far-reaching effects for downstream users. And those unexpected changes lead to frustration, they lead to friction, they lead to trouble tickets, they can lead to outages even. And so no one's happy in this scenario, right? It's extra work for users and authors. And manually testing our code is time-consuming, right? It's what, a checklist of do this, do that, run this, make sure this combination of inputs works. So that's really time-consuming. It's error-prone. You miss things. How do you make sure we get the consistent set of tests run every time we change our code? Luckily, there is a solution for this. That solution is something the software development world has known for a very long time, and that is automated testing. And really here, automated testing, we're talking about techniques that have been used for decades, really, in software development, and it refers to a systematic approach to testing, using software tools to automate what was otherwise a manual process. So here we're looking at verifying the functionality of our code, getting that unit and integration testing, and identifying those errors up front. And ultimately, this is going to help us improve the quality of our code. We get repeatable tests. We can pick up those changes early on. We can reduce that friction and frustration with our end users, and ultimately the toil that comes back onto authors. It also helps us enable collaboration on our modules. If you have multiple people helping develop a module, if those tests are consistent and defined in the code, now everybody who makes a change is going to get those same tests run in a consistent manner. And of course, we all know and love declarative infrastructure, right? This is a Terraform session after all. Why wouldn't we also take a declarative approach to testing? That just makes sense. So you might ask yourself, and it's a good question, right? How are these tests different? How is testing different from the other validations we already have in Terraform, right? We've built up a number of features over the years, things like validations, conditions, checks, right? So breaking it down a little, it really comes down to who the audience of each feature is. So things like input variable validations, custom conditions, the checks that were just introduced in Terraform 1.5 a little earlier this year, these are really for the consumer. They're part of the provisioning lifecycle. They're meant to surface errors to the consumer that are relevant and actionable by them during use of the module. On the other hand, tests are producer-centric. So we look at this producer-consumer model of how we develop and release modules. Tests are meant for the developer. They're during the development lifecycle. They are completely outside of the provisioning lifecycle. They are meant to validate behavior during development. And ultimately, other than producing more reliable code, they're not exposed to the consumer, right? The consumer does not need to worry about the tests. When you run an application as a user, you don't care about the tests that are baked into that application that the developers were writing and executing. You just care that it was done and you got a quality piece of code, right? So that is the main kind of breakdown between these various features that we have. And just to kind of summarize those, right? Input validations we introduced all the way back in version 0.13. They've been around a while. Their scope is input variables. Pre and post conditions, a little more recent. We introduced those with Terraform 1.2. Those are also targeted at the consumer. They will block a run if they fail. That's another distinction here. But those are scoped to an individual resource, an individual data source, an individual output. Checks, again, I mentioned, are our newest, were our newest addition. They were introduced in Terraform 1.5. They're really meant for holistic functional testing, post-plan, post-apply. And the scope is the entire configuration here. This is also our main interface to our Terraform Cloud feature, continuous validation, which is going to continuously, in the background, evaluate those checks and surface errors if they fail. And then tests are where we switch from the consumer audience to the producer audience, brand new in Terraform 1.6, as you heard earlier in the keynote. And again, the scope of this is the module, and these are separate from the plan and apply cycle. So that's just kind of breaking down how these different features interact and how you might use them all together as a unified validation suite for your modules, because they really do serve different purposes, and put together they can make some really, really high quality code. So let's talk about the Terraform Test framework. Again, as we heard in the keynote, Terraform 1.6, GA as of last week, and it introduces the Terraform Test framework. Now, you might be aware that there's been an experimental test command and test framework in Terraform since version 0.15. This is the evolution and the conclusion of that experiment now in a GA form. So this new framework replaces that previous experiment with the new final testing framework. And this is our systematic approach to testing for Terraform. A big benefit here is you write tests using HCL. You don't need to learn another language to write tests. It's familiar syntax. If you know how to write conditions for input variable validations, for pre and post conditions, you already know how to write tests and assertions for test conditions. We reuse the Terraform test subcommand that was part of the experiment. That is how you will execute tests, again, separate from plan and apply. And these are stored alongside the module, but not in the module code. And that's important. We store them in a tft-test.hcl file. And it's important because that means you don't have to break the downward compatibility of your module in order to incorporate tests. Because they sit off to the side in a separate set of files, they're not in .tf files, you can maintain that downward compatibility of your module while still taking advantage of tests. And then because tests are going to run actual plans and actual applies for integration tests, we're going to execute those in a temporary in-memory state, so we're not impacting live resources. And then also clean up any resources created during the tests. So taking a quick look at what a simple test looks like, we have variable values here, and these are going to supply the input to our module during the tests. So these are going to be the values that are going to be fed to the module as the test runs. Looks like the font got a little off here. Sorry about that in the alignment. We might be missing a font. But the next part is we need a provider block. So our tests are going to run plans and applies. They need provider information. Typically, a child module is not going to include provider blocks because that's supposed to come from the calling module. So for our tests, we need provider blocks. And then we have our run blocks, one or many potentially run blocks, depending on all the tests you want to do. And each run block has a command. By default, it's going to be apply. You can also run a plan for unit type testing. And just generally, I would encourage just put the command in there, be explicit, right, every time, even if you're going to default to an apply. And then we have 0 or more assertions. And these are where you can really dig into the behavior of your module, get into those custom conditions. They're not required. You could just simply run a plan and catch any errors. Simply run and apply and catch any errors. But those conditions and assertions really let you dig into the behavior of the module. We can also optionally, within a run, have variable and provider blocks that customize that one run versus the top level blocks here at the top of this file. So we talk about unit testing. These are the things we can know at plan time. These are things like modeling different combinations of input values, checking our conditionals, checking our logic, making sure we're getting the right outcomes we expect. And these we can run as a plan, right? Validating string interpolations, finding consequences if we're doing some refactoring. We also have this interesting ability to test for things that should fail. So we talked about preconditions, we talked about input variable validations. You want to be able to check that, okay, if a user feeds a bad value that should cause one of those things to fail, does it actually fail? And frankly, I caught in one of my own modules a mistake I had made in a regex expression that was letting some values through that it shouldn't have, and the test framework caught that for me. So again, testing those input variable validations, preconditions, and checks by adding an expect failures attribute. It kind of reverses the logic of the test. So now, if it doesn't fail, that's a failed test. So an example here is of that first technique I talked about having multiple input variations. So here we have some top-level variable values that are going to apply to all of the test runs within this test file. But then lower on here, and again, it's a little misaligned, but here we see we have another variable block inside a run. And so for that run, those variables will win. Basically, it's a precedence thing, right? So if you can override values within a run, we can now customize different runs. Say, have a different provider block to run various runs against different regions. And so those would be some of the use cases there. So this is that expect failures condition. Again, I have in my variable file, I have an input variable validation, just checking for a valid CIDR block. In the test run, I'm going to feed it using a nested variable block. I'm going to feed it a bad CIDR. A /0 is not valid. And so that should fail. And so I'm going to tell the Terraform test to expect a failure on the CIDR block variable. We can do that with resources, with preconditions. We can do that with checks as well. Moving on to integration testing, our use cases here are the things we can only know after apply. I kind of set up the question in the earlier slide of, well, I can run Terraform plan, like isn't that testing? And the answer is no. There are things that do not show up during a plan. Problems like calculated attributes not coming out the way you expected, right? You can't know those during a plan because they are calculated during the apply. Using an integration test and an apply test, we can check those values. Also things like missing permissions. Features or APIs that are not enabled in your cloud account or in your region yet, right? We can tease out those kinds of things. As well as, I run into the case a lot where maybe you're bringing in a JSON string into, say, an IAM policy. The plan doesn't know that that's invalid JSON until you actually try to attach it to that policy. So these are the kind of things we can test for as well. Also interoperability testing. Again, I was talking about detecting those inconsistencies between regions, partitions, right? Commercial versus GovCloud. There are differences. You can run test runs across both regions and see how your module behaves in each one. Also validating the impact of new Terraform versions, new provider versions, new child module versions you're using, right? Run a suite of tests against a new version of Terraform, against a new version of that provider before you make them available to your downstream users. So some examples of those here. We have a simple end-to-end test. It's running command of apply. And we're going to do some, oops, I went too far, but we're going to do some assertions then against calculated values that we couldn't know at plan time. Another thing we can do here, which is really powerful, is actually have a module block inside the test run. What this is going to do is tell for that test run, say, hey, instead of running the module I'm testing, run this other module. The use case here is helper modules. So let's say, in this case, I have a module that expects the user to bring their own networking to the party. Well, for my tests, I need somewhere to run them. So I can use a helper module, a setup module, to set up some networking first. That's only going to be there for the test. Run the tests, reference that, that previous run. Again, yeah, the box is a little misaligned here. But you can see the VPC ID variable there is referencing that setup network run and an output from that other run, so we can chain runs together like this and use helper modules to get really, really complex with this. So these are just a few simple examples that really are just scratching the surface. Hopefully you can see some of the power of this framework and what you can do with this. And again, all in HCL, right? You don't need to learn Go, you don't need to learn Ruby. We don't need to learn anything new in terms of that. All right. Moving on, now that we have this framework available to us, how do we automate it, right? We want to make sure that those tests are being run. It's one thing to write the tests, but how do we know that they were executed? Best way to do that is to make it a first-class integration in the Terraform Cloud module publishing workflow, which is exactly what we've done. First off, to set the stage, we have a new approach for publishing modules in the registry. This is available as of today. It was turned on earlier today. So now, instead of the tag-based model we've had all along for publishing new module versions, we have a branch-based model. You can take existing modules and flip them over to the new model. That is completely fine. But this really gives us some more flexibility around the module publishing workflow, and it moves that control from the Git tags to the private registry. So we actually publish and set that new version, pick the commit that it's going to be associated with from the private registry. Tag-based publishing is still there, it's still available, but this new branch-based workflow enables for us the test-integrated publishing workflow. So this is where we bring those automated tests into the private registry publishing workflow. And again, this is available today as a public beta in Terraform Cloud for all organizations. And again, we want to make sure those tests are successful before we choose to publish a new version of the module. So as a platform team, right, we can see that those tests have occurred, that they exist for the first, the first thing. But as commits occur, as pull requests occur against that branch, again, this is why we have that branch-based model, we're going to watch those pull requests, just like the VCS integration we have in workspaces. This is going to look very, very similar now in the registry for modules. So we're going to see those run results. We can dig into each one of them, see the passes, the failures, right, what's going on with each assertion and each run within all the test files in our modules. Just like workspaces, we can initiate these tests via the CLI, via the API, and also through direct VCS integration. So with VCS, again, we're watching that branch, we're hooking on that branch and going to automatically run on PRs and commits and merges to that branch. And then from the CLI, we introduce a option to the Terraform Test command, the Cloud Run option, which I'll show you in a bit. Now, as you heard in the keynote, we know it's difficult, it can be difficult to get started with a new framework. You might not know what tests to write or how to write them. And so to get you kind of jump started on this, we have introduced generated module tests. So with the push of a button, you can generate a test suite for any module in your private registry. This is available today as a private beta for Terraform Cloud Plus tier customers. And this is leveraging a large language model. We've specifically engineered it around HCL, the Terraform Test framework, the kinds of things to generate it. Because we know privacy is a concern with LLMs and with some of these new AI tools, be assured this is running in a HashiCorp controlled environment and we are not using your module code for training. So that's not going to leak out to anyone else's results. But this is just a great way to get started with writing tests, see the kinds of things you can do with tests. All right, and with that, let's get into a demo. And just like the keynote, I am going to tempt the fates and do a live demo. All right, so starting out here, I'm in my private registry. I have a module that is using the traditional tag-based publishing approach. You see I've got a few versions here already available. I've also enabled it for no-code provisioning for my users. And the new thing you'll see here in every module is the testing section over here on the right. And because I want to get started with this, let's generate some tests. Now, the amount of time this takes will depend on the size and complexity of your module. It can take a few minutes potentially to get those results back. Luckily, we can just close this and come back to it later and get those results. So that's what I'll do in the interest of time. But the next thing I'm going to do is we have this new publishing settings option. I'm going to change this module from tag-based to branch-based. And all we need to do is give it the branch that we're going to watch. So I'm going to watch the main branch. Notice my previous versions are still there, so doing this switch has not broken anything for any downstream users. Those previous versions are still available, but going forward, we're now going to publish from the registry instead of publishing via Git tags. Now that I've made that switch, I can configure tests. So here in the configure test screen is where we enable or disable integrated testing for this module. And it's also where we're going to set up environment variables for those test runs. Typically, this is going to be your provider credentials that you're going to need for those test runs. Your other actual input, Terraform input values are going to come from the TF test file like we saw in the variable blocks. But these are going to be the environment variables that are needed by those test runs. So in this case, I've got some AWS credentials in here. Now, let's take a look at that way. This is the test code that I have written for this module. So again, going through some of these techniques we have, I'm specifying a bunch of values for my input variables. I have my provider block here. Because I know my credentials will be coming from the environment variables, I only need to give the region to the AWS provider. And then we'll start out with a unit test. Pretty simple test here. We're going to run a plan command. and just check a few assertions on values that are known at plan time. In this case, I'm using the bucket prefix option on the S3 bucket. I can just check that I'm building that prefix using some of those input variables with a validation or with a interpolation. I just want to make sure it's coming out right. I didn't miss a dash or something in my interpolation sequence. Next, I'm going to do some input validation testing. So again, I'm just going to run a plan here, but I'm going to now feed some invalid values to this test run. These are things that should cause validation failures in my input variable validations. And then for each of those, I'm going to say, hey, Terraform, expect a failure here. If one of these doesn't fail, if it lets one of these values through, that's a test failure. That's a problem. Again, doing the same thing here with a precondition. So I'm actually testing a precondition here that I have in this resource. So that shows using a resource address instead of a variable for an expect failures block. And then I'm going to do an integration test. I'm going to actually create this bucket. So now I've switched to an apply command for this run. And I'm going to assert a condition. I'm going to check actually the final bucket the bucket name value, which I couldn't know at plan time because I'm using the bucket prefix. So that auto-generated string is going to get tacked onto the end. I still want to check that, make sure that the beginning of that generated bucket name is what I expected it to be. This is a value I can't know at plan time. I can only know it by doing an apply. And then finally, I'm going to use a helper module to actually validate the website is running. So here we specify a module block inside the run. This case is just a local, very tiny module I wrote just to do a simple HTTP check and get a value back. This could be a module in the public registry and the private registry where you can source modules as normal using those module blocks. I'm going to give that an input variable of the endpoint that came from the previous run. So I'm going to use that end-to-end run, that integration test run, to feed this helper module or loader module that is going to actually assert that we got a 200 status code back. So let's go ahead and run Terraform Test. And I'm just running this locally. And we see all of those runs are going to process. The apply run takes a few seconds longer to actually do the thing. And now you see we're going to tear down at the end of that test run. So great, everything's passing. The downside is I had to have provider credentials locally. And yes, these are redacted. You can see the ... They're time-bound anyway, so. But you can see I needed to have those provider credentials locally because those tests ran locally, right? And we know we want to avoid that, and that's why we've also integrated this with Terraform Cloud. So let's actually break something. What I'm going to do is come back here to my input variables. This could be anything that's broken. I just want to show you the experience when something is broken. So I'm going to change that to dev. That's going to change what the bucket name is going to result in because I'm using that environment variable to help build the bucket name. Now it's not going to match my test conditions. So just to kind of simulate a failure here. But this time, instead of running it locally, I'm going to use the cloud run option to run this in the registry. And because I enabled testing in my module, actually let me double check that I actually hit the enable button. Yes, okay, so I enabled it in the registry. I can now use the cloud run option to Terraform Test along with the source address of that module in the registry. This is the same address as you would put into the source attribute of the module block. And now instead of running locally, we're going to start those tests up in Terraform Cloud. So if we go into view all tests here, we see they've already been queued. They're running in the Terraform Cloud environment instead of locally using those environment variables that I set up on the module. They're stored securely in Terraform Cloud. They're not sitting on my laptop. I don't need them on my laptop anymore. And as you can see, we're going to run through all of those tests that I've defined in my file, and, well, I've got a failure. Right, so this is the experience we get when we get a failure. I can see I have several past runs, but 2 of my runs have actually failed. And we get the exact condition that failed, why it failed, and that custom error message that I put as part of the condition. This also becomes really obvious, as we saw in the keynote demo, right on the main page of the module. So if we're coming in here to publish a new version, we can see right away, wait, there's failing tests. We might not want to publish this yet. So getting that information surfaced right up. So now, let me fix that issue. And I will just make a change that causes me to need to recommit this. This time, I'm going to rerun my tests through the VCS integration. So as you're developing tests, as you're developing the module code, right, running from the CLI is a great option. You can do it ad hoc. It's going to push up whatever's in your working directory and run that. But now we want to actually run that against the VCS workflow. So I'm going to open a pull request. I'm going to open a pull request against the main branch, which is the one we're monitoring when we set up the branch-based publishing. We can see I've got a few changes here, and I will just go ahead. Oh, come on, GitHub. Oh, there it is. I'm in the wrong pane. There we go. Okay, if our internet connection is working okay. That's going to open the pull request, and we should see here we've already got test queued. So we've gotten that webhook notification from the VCS integration that, hey, a new PR has been opened against the main branch. We need to run the tests. And so we can see now this was triggered via GitHub. We see what branch it was triggered against, and we can see those tests running. And if all goes according to plan, they've passed, we're happy. Our next step is going to be, all right, well, it's time to merge that pull request. And since my pull requests interface is having some fun, let me go actually out to GitHub. And I should have an open pull request. And I will go ahead and merge that. Now that I've merged it against the main branch, we're going to get another set of tests kicking off here because now we have a merge against the main branch. So we'll do one last set of tests. Now you can see we're running against the main branch, against that merge commit that I just made. And when everything looks good here, again, here's, we see the whole history of tests that have run against this module. Okay, we got good pull request, or we got good tests against our merge. We are now ready to publish a new version. So we come back here to the module page. We click Publish New Version. We're going to pull all the commits for the branch that we're monitoring. So we can see I've got that new merge pull request commit. I'm going to select that one. Simply give it a new version number and publish. And refresh here. We'll see that version 2 is now available in the registry. And hey, look at that. We've also got our test files generated. So again, like we said, the test files won't necessarily be perfect, right? But it's a good starting point here. You can see it has actually generated some input variables that are actually going to pass my validations, right? So it has looked at those variable validations. It has figured out that these will be valid values. It's generated several runs. Depending on the module, you might even get multiple test files generated here. So it can generate some pretty comprehensive suites. But again, I can just copy that out to my clipboard or download a zip file containing all the files that were generated. All right, so with that, we'll switch back to the slides, and I'll just leave you with some resources. As always, developer.hashicorp.com is the best place to get started. That's where we have all the documentation, the tutorials. There is a tutorial out there about the Terraform Test framework. It also goes into the publishing workflow. We released the original tutorial last week with 1.6. We refreshed it this morning to add the Terraform Cloud bits. HashiCorp.com/community to engage with the community. And go to HashiCorp.com/products/Terraform to learn more about Terraform Cloud. And with that, Thank you very much.